Hello, everybody. Welcome to the EVM Working Group's weekly update. This is our first update in 2 weeks today. Last week we were very busy with planning for Q2, so let's catch up here. I'm sharing my screen. Hopefully everybody can see that. Our current goal has changed at long last. Now we are no longer working towards a testnet deployment, we are working towards the mainnet. Testnet was deployed a couple of weeks back. We are still finishing supporting documentation for it and standing up proxy servers and so on, so that people don't have to do that themselves. But we are shifting towards thinking about the mainnet release, and that will happen during Q2. We will share a more detailed roadmap next week. So let's do the weekly updates. Alex.
Yeah, so on my side, I was heavily involved in management of the Aurora release. As probably some of you have seen it with the Rainbow Bridge release, it includes not only the product itself, but also some partners that are using this, and also some incentives for people that are starting to use it, marketing support and stuff like that. So I'm trying to align this. Then together with Arto and Marcelo, I was working on, I was designing the initial draft for bridge and ERC20 tokens inside of EVM. And we have finalized the design of this yesterday. So right now we know how to do this. Pretty convenient and straightforward way. It will be simple to implement with existing bridge infrastructure. Yeah, and also I was fixing some of the bugs with the Rainbow Bridge, which are not that critical here. But one of the things that I want to mention is that Berlin hard fork happened yesterday, and unfortunately it caused the downtime for the bridge for half an hour or something like that. We needed to update Geth instance. It was not working properly. Yeah, but in general, everything's good moving forward.
Fix the bridge issues to do with the Berlin hard fork. Yeah. Okay, and on my end, I was unavailable away from keyboard most of last week, but this week catching up and did a whole bunch busy week. So we did, of course, the Q1 review and Q2 planning, which we'll present next week. I've been working on the CLI and client library in order to facilitate use of the EVM. A bunch of work on those. Let's see anything particular to mention. It's just fixing quality and improving usability. Most importantly, I've been working on the relayer this week. So the relayer was at a prototype stage still a couple of weeks back, and in order to be able to offer public endpoints, we need to move that towards production readiness. So there's a substantial amount of work on that, improving the quality, simplifying, improving the Go Ethereum compatibility so that we return the same error codes and so on, and validating the supported methods one by one. So the most recent matrix can be found here. This table is up to date, and a lack of an entry means hasn't been fully validated yet. Green means it's fully okay. Yellow means probably working, but something still to be done. And red, we want support. Also, I put in place some CI for all of the Aurora projects that I'm working on. I would recommend everybody does the same. We will come back to that question later. And of course, I supported the team with the usual questions and reviews and merges. Now for next week, I'm working on mostly documentation updates and the infrastructure, and supporting the partners who actually wish to use the EVM, of which there are now several. Yevgeny.
This week was testing with Aurora engine, and I successfully complete NEP 141 testing fungible tokens and fixed bugs related to EP 712, and I think for that time we covered about 80% of integration tests. Most difficult part related to sign-in message for EP 712, and I think in first part of next week we should complete our testing.
So come again regarding the 80% of integration tests. You mean the integration tests that you would like to see, or some existing set of those?
I mean integration tests for functionality related to S connector related to fungible tokens, and for near accounts and Ethereum accounts.
Okay, so in other words, the set of planned integration tests you consider 80% complete.
Mm-hmm.
Okay. Let me mark that here.
Evgeny, most probably later during this call, let's discuss the EIP 712, because it seems like in the new version of the of how we are going to bridge stuff, perhaps we do not need this functionality. So users are going to actually use some other ways how to withdraw funds from the EVM.
Yeah, let's put that on the agenda. You can maybe present, Alex, the design for the ERC20 connector.
Sure.
Okay. All right, and Frank.
Yes, so the EVM bully sends the Borch encoded data now to the Aurora engine for begin chain and begin block. I also added exponential backoff for transactions, because when you run them on the test net, sometimes they fail. While implementing that, I also found a bug in the JavaScript API. Basically, exponential backoff there was incrementing the counter twice. The Aurora engine sets the chain ID correctly, and so it was possible to replay transactions until set the begin chain, all the blocks, and then the first transaction, which then fails with fatal error. So the chain ID check works, but then it fails with some internal error, which is still marked in the engine as a to-do. And basically, we can go from here in multiple directions. I think the most pressing one is to have better error messages bubble up from the engine, so I can iterate from there and see what the causes are. And other things that we need is run it locally, batching, and transferring Genesis state to the engine.
Genesis state to begin the run. Yeah. Okay. We don't have Ilya today, I don't believe. And Joshua's updates, let me see here. Right, so Joshua's updates, he's working on the BN128 precompiles. So those are still for the Istanbul hard fork. We had to re-implement those, for context here, we had to re-implement those given that we basically rebooted the EVM implementation in February, going back to the contract, EVM as a contract approach. So he's porting over the code from near core that we had there previously. However, the complication is that for near core, we didn't have to care about no STD, and now we do. So he's porting a library that will be able to complete the implementation. Okay, Michael, welcome full-time to the team. Very good to have you with us.
Thank you.
How has your first post-onboarding week been?
Good. Yep. This week I was doing some review of the code, obviously, just to make sure I'm familiar with what we've got. And I was reviewing the ETH connector stuff a little bit. That's all looking pretty good. I submitted, a small addition to it. And I was working on the issue that's opened about the contract size, the binary size.
Yeah.
So I did get to the bottom of it, but the answer is not very satisfying. So, I mean, I don't know if we want to do too much detail here. I did put several comments on the issue, so I can go into more detail if desired. But the long story short is we probably won't be able to fix it in the near future. We'll have to wait a little bit.
Okay. Yeah, I saw the comments, and sounds like given this dependency, we are not likely to be able to fix it. But hey, I mean, at least it's triaged, and we know what the reason is, and we can plan to someday to fix it. So this is good. Okay, so this has been troubleshooted then. We can probably either defer or even close that if we have no chance of fixing it in the near term. Okay, and I saw also your comments on the Ethereum, the S connector PR here. So you did a bunch of review here. Oops, not that one. We have so many here. Still need to. Yeah,
we had some back and forth, but ultimately, I think the PR is in pretty good shape.
Okay. Very good. And yeah, let's talk about. Do you still have something to do from this week's to-do list, or you can take new tasks?
I could take a small task for today. I'm mostly waiting for the pull request number 24 there to be out of draft before I continue reviewing there, because it seems like I got to a section that was still very much in flux, so I didn't want to inundate them with too many comments until they're ready for that. So.
Okay. Yevgeny, how do you feel about coming out of draft? Is that something next week? Yevgeny, for your pull request number 24.
Yes, I think so.
Okay, so we can. You're not planning to push too much more to it, or how does it look from your end? It's mostly testing now, I see.
Yes, I think we should for testing probably will be good idea next PR, because we fixed all bugs that we found with Kirill. But yes, I think we should merge it.
Okay. All right, then what I would plan to do here is that I will deploy a new version of the contract as it is now to testnet and betanet, and after that we merge this, and then we give it some time to stabilize in master before we deploy upgrades. So merge happening in the next days for sure. Okay, so discussion. Oops, that was the old one here. Next week we have a benchmarking task that we need to talk about. But Alex, why don't you begin with presenting what you did on the ERC20 connector? I'll stop my sharing.
Or can you give me also the host? Or okay, no, I can do it right now.
Okay.
I don't need to have a host. Are you able to see my screen?
Yes.
Okay, so this is a little bit complicated thing, but I will try to spend not a lot of time here. So the way how the connector for the ERC20 connector is working right now is the following. There is a locker account or a locker contract on the Ethereum side. The locker account, if a user would like to lock some tokens, it calls the lock method of the locker account. And this lock method does transfer from the sender and emits the event. this event, for this event, then we are able to build a Merkle proof, which can be submitted on the near side to a contract that is called factory, to the method deposit. So this proof is submitted there. It is decoded and verified, and at the moment when it is decoded and verified, it calls the Ethereum client on near, Ethereum-like client on near, and approver contracts. And then when everything is done, then there is a separate contract, which is the NEP141, that corresponds to the ERC20 that was locked on the Ethereum. And then this contract is actually minting the tokens and transferring it to the users. This is how the thing was working before EVM is there. Now we need to figure out how we are able to breach things inside of the EVM, inside of the Aurora. Moreover, it will be super cool if we will be able to breach into Aurora not only the breached ERC20s, but also any NEP141s. For example, one of the examples of the near native NEP141 is wrapped near. So it will be pretty cool to breach it into the EVM. So here is the way how we are going to update the factory, and also what we are going to introduce on the EVM side in order to allow these transfers. So first of all, we are going to change a little bit the way how factory works. And the way how we are going to change it is the following. In the lock-in event, we see here the recipient of the transfer. Previously, we have been using this field for near accounts only. So this should be a valid near account. Obviously, we do not check it on the Ethereum side. So this is just a string. Now we are going to treat recipient in a different way. If this string is not having a column inside of it, a column, just to remind everybody, column is restricted in near addresses. If it doesn't have a column, then we treat it as a just plain near address, and we are just doing absolutely the same as we were doing. So in this case, I'm saying that the message is null. Yeah, so there is nothing after. So there is a method analyze. Yeah, recipient. So there is nothing after the column, or the column is absent. So we're just minting. We're just asking NEP correspondent NEP141 to mint some tokens for the user. However, in case there is something after the column, and the column is presented there, then we treat this as some kind of message that needs to be transferred to a smart contract that comes before the column. So literally, we are calling an NEP141 function that is called FT transfer call, that is specifically designed to transfer some tokens to a smart contract and call a function inside of this contract. So the way how this transfer call is working, and we are passing message to this call, and also a predecessor ID, or the contract that, or like the user who is calling this function, calling this deposit. So the way how FT transfer call is working, it just adds. So this is the function in NEP141. It transfers the tokens and calls a function, a specified function that is called FT on transfer in the recipient contract. And it says what is the amount that was transferred, and it passes the message there. And then this FT on transfer returns the unused tokens, and the unused tokens are returned back to the user. So pretty simple call. And now we are making our EVM to have an FT on transfer method. Yeah. So in order to, so I'm saying, so if the user, one step back, if the user would like to transfer something to the EVM, to inside of the EVM, they need, as recipient here in the first lock-in event, say that this is Aurora column, and then some additional information. And in a second, we will see what is the additional information. And then NEP 141 does the FT on transfer call of Aurora contract or the EVM contract. So we have this function here, FT on transfer. And from the message, we are actually getting the information who was sending, who is the actual recipient of the transfer, what is the Ethereum address, who is the recipient. For inside of the message, we will see the fee to the relayer, and since we have there a predecessor ID of the caller, we have the relayer, the near account of the relayer. So we are decoding the everything here from the message. So as simple as that. And we also know the token because this is the predecessor ID of this call. So at this moment in time, in this function, we know everything about this transfer. So what we can do, we can check we can figure out what is the token. So we need to have some kind of mapping of tokens of NEP 141 tokens to ERC20s or like Aurora ERC20s, yeah. And then we are able to mint some tokens there. And in case specified fee is not 0, then we can find a respective address in the mapping of the relayers, yeah, because here the relayer in this line is the near account, yeah, and we need to figure out where to send the fee that was specified by the user. So we need to have a mapping of the relayers, and we are just going to send some fee to the relayers from the recipient account, and this is how users are going to pay to relayers.
One small note, so FT on transfer, I think, currently has a separate argument for the sender, so you don't have to encode predecessor ID in the message because, well, it's normal functionality. Any account that receives fungible tokens wants to know which contract or which one sent it, so there is a separate field for that. No need to.
Yeah, but the sender was, the factory. So we need to check. We need to make sure that. Well, obviously, we do not want to use the sender ID because it has some implications similar to Ethereum implications. So we need to some kind of understand how to pass the person or like the account that was called in the factory deposit method that resulted in call of the NEP FT transfer call that resulted in call on FT on transfer. Yeah. So let's take a look at here. So this is the way how we are passing the information to EVM. And now the question is how we are going to allow people to withdraw tokens from the EVM. And in order to do this, we actually need to add a precompile that we can call exit to Ethereum precompile. And this is a separate contract. It will be on a fixed address located in EVM. And it will have one method, withdraw. Yeah, so ERC20 amount and recipient. And this precompile, what it will do, it will actually check that the user has enough amount of ERC20. It will be able what it will do, it will remove or like burn some ERC20 from the user and call. And so Aurora is going to call a method of the bridged NEP 141 that is called withdraw. This is the natural way how the bridge is used right now. A user needs to call withdraw of the token contract. This specific method, it is very specific only for, and it exists only for the bridged tokens. Yeah, so there is a precompile. User calls it with an ordinary EVM transaction that can be signed by MetaMask. And then Aurora at this moment does the cross-contract call to withdraw function, and then everything works as usual. So this withdraw then calls factory, the finish withdraw method. Then there is a specific receipt ID created, and then the receipt ID, from the receipt ID we are calculating the light client proof, and we are putting this proof on the Ethereum side in the unlock method of the locker. The good thing about this is that we can do absolutely the same for also not bridged tokens. Yeah. So if we have a separate NEP 141, for this we would need to have an ability to transfer this inside of EVM and outside. And the good thing is that we are going to use absolutely the same methods. We're going to use absolutely say FT transfer call. So if a user who owns some wrapped near will do an FT transfer call to Aurora with a specific message, which specifies in this case, 0 fee, and also the message who is going to be the recipient of these funds in the EVM. Then he will be able to transfer this wrap near to Aurora. And in order to withdraw, we need to create an additional precompile, which we can call exit to near, and it will work almost the same as the exit to Ethereum precompile, with the difference that it is not going to call withdraw function, but is going to call the FT transfer function, and this transfer will transfer tokens from Aurora to the near user. So to conclude, just to give you a sense of what contracts are holding what tokens. Yeah. So on the Ethereum side, in case person is transferring ERC20s to near, it doesn't matter whether it is going to be a near native runtime or EVM or Aurora, the user eventually transfers his tokens ERC20 to the locker account, and ERC20s are stored in the locker account. On near side, tokens either if a user is located in the near native runtime, then the tokens are stored in his account, and the tokens are they specified in the NEP 141 contracts that are individual for every bridged ERC20. In case a user would like to work with Aurora runtime, then the contract that is storing his tokens is actually Aurora. So Aurora stores the tokens. However, inside Aurora, we have ERC20s, or like Aurora ERC20s, and inside of that contracts we have the specification, the mapping of what Ethereum addresses are owning what tokens. So yeah, multiple layers, dream inside of a dream. But this is the most natural way how to implement this and make it interoperable with all of the NEPs 141.
Okay. Did you already discuss this with Marcelo as well?
Yeah, that's correct. So we have discussed this with Marcelo, and so he's pretty clear with this. He understands it fully, I would say.
And the plan is that he will implement this?
Yeah.
Okay.
He will probably need some help on the EVM side, but he's keen on learning this stuff.
Okay. Well, he can come to me as a first point of contact, and then of course maybe Evgeny Uhanov will also be able to help him, and
Cool.
certainly need to align, given that they will be dealing with the same callback functions, both of them.
Yeah. So this is wanted to mention for Evgeny that for ETH, like bridged ETH, as you can see here, the actual NEP 141 contract and Aurora contract, they need to be merged together. So we are actually going to schedule the FT transfer call from Aurora to Aurora. So this is going to be a little bit more complicated and a little bit messed up. But in general, everything is going to work absolutely the same way as with any NEP 141 here. And as you can see, there is no need here for the user to sign EIP 712 transactions, which is kind of cool. Though at the cost of the introduction of 2 additional precompiles in Aurora. So let's sync on this, Evgeny, with you, and once again go step by step with this stuff and understand what needs to be changed for the Ether connector.
Okay, and I put in your Miro board link here as well. people can request access.
Cool.
Yeah. All right. So for next week, a couple of important things. So of course, we're going to finalize and publish the roadmap and OKRs for Q2. That will no doubt be of wider interest. Now there's a question and an ask from Ilya and the contract runtime team that we need to figure out discrepancies in the gas use with aligning with Bo, Nikolai, and Alexei. So Michael, this would be a pretty good task for you, I think, since you're actually pretty familiar with the overall architecture here as well. So I went ahead and created a ticket for you here. It's ticket 31. Currently, the discussion is non-public in Slack, but of course, there's no particular reason for it to be non-public. So you can lift tidbits into this thread, for example. This is really this is a little bit open-ended right now, what the scope of this is. So one of the first things to pin down would be what is the realistic scope in the next weeks. But mostly, as I understand it, we just need to get some actionable intelligence for the contract runtime team, and they will take it from there. So presumably, you would need to sync with Ilya and at least Bo, maybe Nikolai, and then produce some kind of reproducible benchmark that they can iterate on to improve things.
Cool. Yeah, sounds good. I'll take a look at it.
Okay. And then the other big thing next week is the relayer deployment. So I've taken over control of the aurora.dev hostname and set up already DNS entries. Not yet to be announced today, but on Monday we will roll out the testnet and betanet endpoints, and just needs a little bit more work for production readiness on the Aurora relayer code base, and then we're gonna roll those out. Partners are asking for them. So yeah, we got the servers, load balancers, and DNS ready to go. Just need a little bit more work on the code. And we have documentation updates that need to be done. Now, one thought I had, Alex, is that maybe we ought to actually pull out the Aurora specific documentation to a subdomain of Aurora Dev instead of having it in the near docs. It's a bit incongruous there with the with Aurora engine there all of a sudden. So from there we could just link to our own doc site and put everything there. What do you think?
Yeah, I agree.
Okay, so I'll get that stood up, and it'll be easier and quicker to update the docs then as well. Okay, yeah. So the main asks from partners right now, the main asks from partners have been get the relayers going, which I haven't wanted to do prematurely because I knew there were issues with that code. But next week we'll have them. Get the documentation updates so that they can start understanding what's going on. Frank did a first pass. I'm doing a second pass, and as said, let's pivot the documentation to its own site. And the third one is for some partners, it's very important about particular RPC operations on which we either are not fully implemented in the same way as Geth would be, or they need performance improvements. So I'll get those out as well in the next week. So that's pretty much it for on my end, unless somebody has something more to discuss today.
Just a short question on the continuous integration. Do we have like a standard we use there? What I should use if I set it up for the bully?
Yeah, it's all using GitHub Actions. You can just take a look at. You have a Go code base, but it's pretty much the same .github workflows, and then just a little bit YAML configuration. And
okay. Just wanted to make sure that's what we use everywhere. I did that before for Go, so I can leverage that.
Sure.
Right.
Yeah, and of course I recommend that in all our projects. I know this might seem old-fashioned for some of you, but let's have a make file, and that make file will build the project. As in, if somebody needs to figure out how to build the project, just type make, and it's going to build the project. And it can have other useful things, like the unit test can be run easily. That's make check is the standard target for that, not make test. But we can have a test as well, and code formatting and so on. So you can just take an example, for example, from the Aurora engine repo. It's not that difficult to write make files. The only thing is there's an invisible tab here. That's the only difficulty about make files. So let's do those instead of some ad hoc scripts like people have used to do. Okay, that's everything for today, and no further topics. Let's end here in that case. Okay, going once, going twice, going thrice. Okay, have a nice weekend and see you next week.
Nice weekend. Bye.
Thank you. Bye.
See you. Bye bye.